All right, guys, we're going to do 4.4 notes, day 1, log functions. Let's get right to it. All right, here we go with our domain and range again. So first let me tell you the point of this. A log is an exponent. So to just understand, just another way to write an exponent, okay, it's a tool we're going to use to solve something like this. Look at that thing. Doesn't it look so easy to solve? But it's not so easy, right? Is it 2 to the 1.1? Is it 2 to the 1.2? We don't know what x is, so we're going to figure out how to solve those equations eventually. But until then, let's talk about the backstory, the logs. So graphing domain and range. So first thing, f of x equals ln x looks like this. If you put it into your calculator, that is, and by the way, here's natural log on your calculator. This is what you're going to get. You can look at the table and all that. But let's discuss what's going on in this graph. Notice that there is a vertical asymptote at 0, right? So my domain is 0, but not including it, to infinity. And let's talk about why that is. That is because, and by the way, natural log is just log base e, and I'll talk about base in a minute. That is because you cannot take the log, or the natural log, any kind of log, of 0 or a negative number. So let me say that again. You cannot take the log or the natural log of 0 or a negative number. I mean, look at your graph there. Let's talk about range just because we're here. Notice that it goes down forever and it goes slowly up forever. So because of that, it is going to be negative infinity to infinity. Let's talk about log x. Same kind of deal as natural log x. It has a different base, so it's shaped a little bit differently. In your calculator, the log button is right here. And so looking at this domain, it's the same. 0 but not including it to infinity, negative infinity to infinity here. Okay, and just remember, you can't take the log of a negative. Let's look at this over here. So natural log, square root natural log x. So when we graph this, it looks similar to this. I call this the creepy arm. And let's talk about the domain. So 1 works and it goes on forever. So 1 to infinity. The range, it starts at 0 and goes up forever. Now why? Why is this true on the domain? Well, you can't take the natural log of 0 or a negative number, but also we're taking the square root of this. So when we talk about domain, remember, everything under here would have to be greater than or equal to 0. But we know that it can't be equal to 0 because you can't take natural log and get 0. So that's why everything is shifted over like it is. All right, and it has to be greater than. All right, so that's why everything is shifted over. All right, and you can always plug them to your calculator and look at them too. So it says, look at those graphs. They show you that you can only take the log or natural log of a positive number. And by the way, transformations will happen today in the homework. They just go how we've always done them, all right? Inside, left, and right. It controls the horizontal, outside's vertical. Okay, so let's talk about these. Exponential form, 5 to the second equals 25, is the same exact thing as log base 5 of 25 equals 2. So I call this the circle. So 5 to the second equals 25. 5 to the second equals 25. All right? And we're going to do some more examples of this, but I call it the circle. It's just like this little whoop, little circle like this. These two things are the exact same thing. And please know how to say it. Log base 5 of 25 equals 2. All right? Natural logarithm just has base e. I talked about that already. All other logs, their common logs, have base 10. Alright, so, moving right along, it says if you see no base on a log, it's 10. If you see no base on a natural log, it's e. So let's go into these. Convert into logarithm form. So this is exponential form. Notice the word log's not even there. So a to the b equals c. Here's how I start it. I write down the word log, and I give myself space and write an equal sign. And what you want to do is this. Okay, it's a little arrow, a little circular arrow I do. So a to the b equals c. Notice that I follow that arrow. I do want to talk about how you write this too. If this is handwriting paper, okay, here's the word log. A should be here. C equals b should be on the same line. If you write this, you will get it wrong. What is that? That's log of base 10, a to the c equals b. All right, that's different. That's different than this. So on this one we have an e. So if you have an e, just use natural log. Give yourself space. I'm going to do the circle all over again. So I'm going to start here. I'm going to go all the way around. So e to the x equals 2. Okay, there you go. So I went from exponential to logarithmic. Now over here we're going to go from logarithmic to exponential. This one's always easier to me. So c to the y equals x. C to the y equals x. There you go. If you need to watch it again so you understand how to do it. All right, let's scooch on down. Find the exact value without a calculator. Oh my. Okay, so, well, we don't know what this equals, so let's make it equal to x. And it's in log form right now, so let's make it exponential form. So 10 to the x equals 100. 10 to the x equals 100. There it is, 10 to the x equals 100. Well, can I change 100 into 10 times 10? So then wouldn't it be 10 to the x equals 10 to the second? Like that. Well, then if this is true, if 10 to the x equals 10 to the second, then look at that. Wouldn't x equal 2 then? If I'm saying 10 to what is 10 to the second, you'd be like, well, it'd be 10 to the second is 10 to the second. All right? Same here. We don't know what this equals, so make it equal to x. It's in log form. You can't do anything with it, so change it to exponential form. So 4 to the x equals 1 over 16. Well, this one's weird, right? I could definitely change my 16 into a 4 squared. But this doesn't quite match up. I have 4 to the x and this 4 squared is in the bottom. So remember your old exponent rules. Remember x to the negative 1 is 1 over x. So we're actually going to pick this 4 to the second up and we're going to put it on top. And since we're moving it from one side of the fraction to the other, we make that negative. Now if you look at this, 4's match and the x is negative 2. So x equals negative 2, like that. All right? So natural log of e to the e. Well, I don't know what that is. So let's set it equal to x. Now this is getting trickier. Do you remember what's down here? If nothing's here, it's an e. There's a whole lot of e's going on. So e to the x equals e to the e. E to the x equals e to the e. So if these e's match up, then that must mean that x equals e. Like that. So on this one here, set it equal to x. Root 5 to the x equals 25. Root 5 to the x equals 25. This one is a blast from the past. Okay, so first thing we need to remember is that square root, and it's been a while since you've done this, but square root can be written as 1/2. Like that. So 1/2 x. 25 would be 5 squared. So then when we're looking at this, the 5's match, and then 1/2 x would have to match with 2. Now this isn't as easy, but you do know that the 1/2 x matches with the 2. And then to solve on both sides, we multiply both sides by 2. And x equals 4. All right? Rewatch this if you need to see it a second time. So let's go down here to example 4. Find a so that the graph of f of x equals log base a x contains the point 27,3. Well, what does a point, like what do those stand for? Coordinates are always written in x comma y, right? And we don't really use y nowadays, we use f of x. So I'm going to substitute in 3 for my f of x, and I'm going to substitute 27 in for my x. So log base a of 27. Now this isn't written the way it's looked in the rest of the notes, so let's rewrite it. So I'm just going to write log base a of 27 equals 3. Now that it's written like the rest of the notes, let's change it to exponential. So a to the third equals 27. Well, I need these to match. I can break up 27. If I break up 27, it's 9 and 3, and that's 3 and 3. So a to the third equals 3 to the third. So now if you look at it, and you match it up, what does a match up with? It matches up with 3. Here we go. All right, this is it. If you need to rewatch it to understand it. And until next time, goodbye.